Okay, this lesson is on ratios and proportions. We're going to start out with just little definitions to make sure you understand what a ratio is. It is a comparison of two values. For example, we have 3/5, or we can write that ratio, comparison of two values. We can write that as 3:5, or we can actually write it out as 3:5. Generally, you see it in one of these two forms. Okay? Proportions. Okay, so proportions, they are equivalent ratios, meaning one ratio equaling another. An example of that could be 1/2 is equal to 6/12. That makes sense. I can reduce 6/12 to 1/2. You usually use a proportion or see it written when you're solving something where there's one unknown. So something like this, that's a proportion. To solve that proportion, you would use the cross product property. But these are both examples of proportions. So let's look at an example. And this example is a girls' soccer team. The girls' soccer team won 10 games and lost 2. So they won 10 games and lost 2 games. A boys' soccer team won 12 games and lost 3 games. Okay, I barely squeeze that in there. Okay, so what we are going to do for this problem is the first part, I'm going to call it part A, is to write a ratio for the girls games, 12 for the girls wins to girls losses. So that'll be the first one. The second one that we'll do is we're going to write a ratio for boys wins to boys losses. And the last one is going to be which has a better ratio of wins to losses. Okay, so let's go back and do part A and part B, and then we can answer C. So girls wins to losses, so that means we're going to say wins over losses. So they won 10 games and they lost 2. So we can reduce that ratio from a 10 to 2 to 5 to 1. It means every 5 games they lost 1. Okay, write a ratio for boys wins to boys losses. So again, it's wins over losses, and they won 12 and they lost 3. So even though they won more games, do they have a better ratio? Well, let's see. If I reduce this, I get 4 over 1. And so it looks like 5 to 1 is a better ratio than 4 to 1. So the answer is the girls have a better ratio of wins to losses. Okay? All right, let's move on. One thing that a lot of times students forget is units. So pay attention to units. I'm going to put exclamation points on that. It's kind of like I'm always tell my students, when you see me write that, I'm screaming something so that you remember what I'm saying. So let's simplify this ratio of 6 yards to 30 inches. Oh, wait a minute. I can't reduce that to 1/5 because we're talking about different units. So I need the units to be the same. So we can take those 6 yards and we can convert those to inches, or we could take the inches and convert them to yards if that would work. Which one is making more sense? Well, I'm thinking going from the larger units to the smaller makes a lot more sense. So 1 yard is equal to 36 inches. So if we have 6 yards and we want to convert those to inches, then we're going to take those 6 yards and multiply them by 36. And that'll go from yards to inches. Okay, so that's going to give me 6 yards is equal to 36 inches per every 1 yard. We'll just put a 1 underneath that. So you can see the yards are going to cancel out. And actually I should have put that backwards, because if you're comparing yards to, pause for just a second so I can clean up my paper. Okay, so if we have yards here over inches, we have to have yards here over inches. And this is really not really liking the way this looks on here, so let's just do it over here to the side. Alright, so if we take 6 times 36, it'll convert that yards to inches. So 6 times 36 is equal to 216 inches. So if I go back and I look at comparing this, that 6 yards is 216 inches, and that 30 inches. Now we have units that are the same, and we can simplify that. And when we do, we can reduce this because, let's see, at least 2 goes into this, 6 goes into this, and 6 goes into that. So you can take your calculator, let's reduce this. 216 divided by 6, I think it's 36, and it is. Okay, so this is going to reduce to 36 over 5. So our answer is it reduces down to 36/5. So let's look at some problems that we're going to solve using proportions and see if you can do this. And remember, whenever you have a proportion, you can use the cross product property to solve that. So solve these proportions. Okay, and as you're solving, if you think you can do it, go ahead and pause the video and solve it. Here's the first one. So they get progressively more challenging. So this one, again, we're going to use the cross product property. If I asked you, how did you know how to solve this? You should tell me I use the cross product property. It follows those rules. So when you multiply down this way, you get 15x. And when you multiply this way, you get 30. And now we just divide both sides by 15, and we get 2 is equal to x. You can check that. 2/3. Does this reduce down to 2/3? And it does. Alright, this one we're going to multiply, and we get 3y. And this one, when we multiply, we're going to actually take 15 times the quantity, y minus 2. Common mistake here is for students to write 15y minus 2 instead of 15y minus 30. I'm going to subtract the 3y from both sides, and I'm going to get 12y minus 30 equals 0. And then I'm going to add the 30 to both sides, and I get 12y is equal to 30. And now when I divide, I get 30 twelfths. Well, I know that there's something that goes into both of those. And what goes into both of those is 6. So then I get y is equal to 5 halves. Okay, last one here, cross multiply. If you can do this in your head, go ahead and take 4 times that quantity and get 4x plus 20. Multiply this way, 16x plus 32. And now I'm going to subtract the 4x from both sides and get 12x. Subtract the 32 from both sides and get negative 12. And then when I divide, I get a negative 1. You can substitute that back in to here, and we get 4 divided by 1, which is 4. And if I put it here, I get 4. 16 divided by 4 is 4. So you can see quickly that your answer is correct. Okay, I have just one more problem to do with you. And then this is a fairly quick lesson. So this next one, we are going to draw a triangle. So let's draw a triangle. And it looks like this. And we're going to call it R, H, S. So directions would be draw triangle R, H, S, where RH is equal to X, HS is equal to 34. Find X if the ratio RH to HS is equal to 3 to 7. Okay. What you're given there is the ratio of the length of two sides. So they're giving you the ratio of two sides. So what I'm going to do is I'm going to go ahead and put the X where the RH is. And I'm going to put the 34 where the HS is. And now I know when I compare these, that ratio, RH over H to S, just think of it as comparing it to itself. That makes sense. RH divided by HS is equal to RH divided by HS. So when I'm doing this, I'm going to replace this with the 3/7. I'm going to replace this with the values that are here. So I'm going to start off with the X and the 34. RH is X, HS is 34. Now, on this side over here, I'm going to focus in on these values right here. RH is 3, HS is 7, and now I was able to set up a proportion that I can solve. And when we solve, let's round our answer to the tenths. To the nearest tenths. So when I multiply down, I get 7x. When I multiply this way, I get 102. And then divide by 7. So our answer is 102/7 is equal to x. Using our calculator, going to be x is approximately 102 divided by 7, 14.57, so 14.6. There's our answer. And let's write units here, since we don't know. It didn't tell us what these were inches, feet, yards, but we are measuring a length, so we can go ahead and do that. Alright, so you're ready to do the ratios and proportion assignment, so have fun with that.